Hello and welcome to the lecture number 16th of this online lecture series of optical instrumentation. And in our previous lecture we discussed about holography. We started module 4, unit 4 of this course. Second part of this course is about optical fiber sensors. Okay. You must have heard in your first year of BTech about optical fibers. You must have studied about the basics of optical fibers. Optical fibers are generally used for communication, but there are non-conventional applications of optical fibers, and one of the non-conventional application that is very important application of optical fiber is the use of optical fibers for making sensors, and those sensors are used for measuring different physical parameters. Okay. So, before discussing about optical fiber sensors, we shall discuss certain basics about optical fibers. So, today in this lecture we are going to discuss optical fibers, introduction, advantages of optical fibers, their applications, their construction, working principle, types, all these things we shall discuss. So, what are optical fibers? They are very thin. Roughly the diameter of optical fiber is in micrometers, around the thickness of a human hair. It is a very thin fiber that is made of glass or plastic, and it is used to carry information from one place to another in the form of light. Normally, the wires that are used to carry information are electrical wires, right, metal based of made of metal conductor wires, but these are made of glass or fiber, and the information in metal conductors it flows in form of current, but in optical fibers the information flows in form of light, right. So, optical fibers are made of either glass or plastic, and most are roughly, the diameter of most optical fiber is comparable with the diameter of human hair, so thin. How light is transmitted? Information is transmitted in form of light, and how light is transmitted? Light is transmitted along the center of the fiber from one end to another, and a signal may be imposed. So, electrical signal is converted into optical form. When it is converted into optical form, it travels through the core of that optical fiber, and at the receiving end it is again converted from optical to electrical format. Okay. Why optical fibers are used? Fiber optic systems are superior to metallic conductors in many ways and also in many applications. Their greatest advantage is bandwidth, very high bandwidth. The frequency of light of visible region is very high, and so the bandwidth is also very high in terahertz range. Okay. Because of the wavelength of light, it is possible to transmit a signal that contains considerably more information than is possible with a metallic conductor. Even if we compare it with a coaxial conductor, even then the speed and bandwidth of optical fiber is much higher in comparison to coaxial conductor. What are the other advantages? Other advantages is electrical isolation. Fiber optics do not need a grounding connection. For electrical conductors we have to ground them, but optical fibers they do not need grounding connection. So, only one wire can be used, one fiber can be used to send a signal, but with electrical conductors we also have to connect a grounding conductor. So, two wires has to be connected even for one signal. Both the transmitter and receiver are isolated from each other and are therefore free ground loop problems, free of ground loop problems. They are electrically isolated from one another because there is no electrical connection. Also, there is no danger of sparks or electrical shock or shortage. Next advantage is freedom from electromagnetic interference. We know there are electromagnetic radiations all over the place. Fiber optics are immune to electromagnetic interference. They are immune. Why? Because the information is in the form of light, and they emit no radiations themselves to cause other interference. So, they do not emit any sort of electromagnetic radiation or any sort of radiation that can create interference for some another device or for some another fiber or wire. Okay. Again, the losses are very loss. Another advantage is low power loss. Due to this, a signal can be transmitted to a higher distance in comparison to metallic conductors. This permits longer cable runs and fewer repeaters and amplifiers. So, because there are losses are very less, so we need less repeaters and we need less amplifiers in the path at which we have to send the signal. Okay. And one more advantage is they are very lighter, smaller, thinner, easy to handle. Fiber weighs less and needs less space than metallic conductors. With equivalent signal carrying capacity, copper wire is about 13 times heavier, in comparison to optical fiber for same signal carrying capacity. It is also easier to install and requires less duct space, while metallic conductor they will need more space. Okay. Some applications. Communication is the major application of optical fiber. It is the application that has driven the growth and development and research of optical fibers. Voice, data, video transmission are the most common uses of optical fibers, and they include telecommunications, LANs, industrial control systems, avionics systems, military control communication systems, all sort of communications, right. But there are some other applications also that are not so conventional, but equally important. Sensing. Optical fibers can be used to design and develop very high end sensors. Fiber optics can be used to deliver light from a remote source to a detector to obtain pressure, temperature, spectral information, etc., etc. It can also be used directly as a transducer. What is a transducer? A transducer is a device that converts one form of signal to another form. Okay. One form of energy to another form. It can directly be used as a transducer to measure a number of environmental effects such as strain, pressure, electrical resistance and pH. Okay. Environmental changes affect the light intensity, phase and polarization in ways that can be detected at the other end of the fiber. Okay. So, light is traveling through the fiber and it is exposed to the environmental parameters that we have to measure. So, these parameters can affect the intensity, phase, polarization of the light traveling through that fiber, and when we can record that change at the receiving end, in this way we can use this fiber as a sensor. This part we shall discuss in details about optical fiber sensors after we discuss about the basics of optical fibers. Power delivery. Optical fibers can deliver remarkably high levels of power for tasks such as laser cutting, welding, marking and drilling. Also for illumination. A bundle of fibers gathered together with a light source at one end can illuminate areas that are difficult to reach. For example, inside human body for medical purposes, in conjunction with an endoscope, Also they can be used as a display sign or simply a decorative illumination. So, lot of applications are there for optical fibers. Major application is communication. Okay. Now, let us see the construction of optical fibers, how they are constructed. So, there are two diagrams, one is cross sectional view, another is side view. So, as you can see, there is a core made of transparent material, either glass or plastic. So, core and there is cladding. Core and cladding both are transparent, core and cladding, such that the refractive index of core is more than the refractive index of cladding, and this is the coating, okay, protective coating. Optical fiber consists of three basic concentric elements: the core, the cladding and the outer coating. The core is usually made of glass or plastic, although other materials are sometimes used depending on the transmission spectrum required. Depending upon the wavelength of light that we have to transmit through the optical fiber, we choose different materials. Protective coating can be one or two layers of cushioning material such as acrylate. Cushioning material is used to reduce crosstalk between adjacent fibers. If there are multiple fibers in a bundle, then or if fiber has to be laid down in such a at such a place where there are a lot of environmental conditions are there, hazardous conditions, then cushioning and more coatings are used. Cushioning material is used to reduce crosstalk between adjacent fiber and the loss increasing micro bending that occurs when the fibers are pressed against through rough surfaces. One basic rule of transmitting signal in form of light without loss is not to bend this optical fiber at a very acute angle. Okay. So, we want to keep it straight as much as possible, because we know light travels in a straight line. So, if we bend the fiber, then there are more losses, and these kind of losses are called bending losses. So, to reduce this bending loss, more cushioning and coatings are used while constructing these optical fibers. So, this is the simplest construction, 3 layers: core, cladding and coating. Okay. So, this is strength material, this is fiber, core, cladding, this is inner coating, this is cushioning or strengthening material, and this is outer jacket. Fine. For greater environmental protection, fibers are commonly incorporated into cables, right. Typical cables have a polyethylene sheath that encases the fiber within a strength material such as steel, Kevlar strands, etc. Okay. So, this is polyethylene sheet. Inside this there is a strength material, then inner coating, and then cladding, and then core, fiber core. So, this is the construction of optical fiber. Now, how light is transmitted? The core is the light transmitting portion of the fiber. Where the light is transmitting? Light is transmitted through this portion inside this core over here. Only in this portion light travels. Light must not go to this cladding. If any amount of light goes to the cladding, it is lost, and if light is lost, signal is lost, information is ultimately lost. Okay. So, the core is the light transmitting portion of the fiber. The cladding is usually made up of same material, but with a slightly lower index of refraction. Refractive index of cladding is slightly lower than the refractive index of core. How much lower? Usually about 1% lower. Okay. What is the use of this making the cladding of less refractive index? Due to this there will be total internal reflection. This index difference causes total internal reflection to occur, and this is the main phenomena due to which the light travels inside the core. The light travels through the fiber to occur at the index boundary along the length of the fiber, so that the light is transmitted down the fiber and does not escape through the side walls. So, this is the very important phenomena that is required for travelling of light through a optical fiber, total internal reflection. You must have studied this in your school, what is total internal reflection. Let us discuss this one more time. Okay. So, over here this is the interface of two transparent materials. Okay. Over here the refractive index of this is N1 and the refractive index of this part is N2, N1 and N2. Okay. Now, what is this? What is this? With refractive index N1 and N2, the refractive index of this part, the refractive index of this part is less than the refractive index of this part. One second. This shows the refraction. So, this is incoming light ray and this is the light ray entering in another material. Okay. So, if light ray enters from a denser medium to rarer medium, then light bends away from the normal, and if light enters from a rarer medium to a denser medium, it goes towards the normal, it bends towards the normal. So, light is bending towards the normal. So, it is entering from a rarer medium to a denser medium, and this is Snell's law. The ratio of the sine of angle of incidence and sine of angle of refraction is constant. Sin theta 1 divided by sin theta 2 is equal to N2 divided by N1. Okay. So, this sine of this angle divided by sine of this angle is equal to this refractive index divided by this refractive index. This is called Snell's law. Now, what is total internal reflection? What is total internal reflection? So, let me draw the diagram over here. Suppose this is core with refractive index N1 and this is cladding with refractive index N2. So, we have seen that N1 is greater than N2, right? N1 is greater than N2. Now, if a light ray is coming in this direction, okay. So, what happens at this surface? The refraction will takes place, and because light ray is going from denser medium to rare medium, from denser medium to rare medium, so it will bend away from the normal. It will bend away from the normal. Now, if we increase this angle, if we increase this angle of incidence like this, so what will happen? This light ray will further bend towards away from the normal, and there comes a angle that is called theta c. There comes an angle theta c. Let me change the color. There comes an angle theta c, for which, for example, this is theta c. The light ray starts travelling along this axis. So, this is theta c, theta c. Okay. This is called critical angle. Now, if we increase this angle beyond this point, if we increase this angle of incidence beyond this point, what will happen? This light ray will come back in this part, in this same medium, and it will follow all the rules of reflection. It will follow all the rules of reflection, something like this. Okay. So, blue color, this is a light ray that is coming on this surface at an angle greater than critical angle. So, because this angle is greater than critical angle, the light ray will be reflected from this surface. The whole light ray will come again, it will not go in the cladding. This part is also transparent, but this light will not go to cladding, it will again come in this part, and this phenomena is called total internal reflection. And it only occurs if light ray goes from a denser medium to a rarer medium, because for this part light ray will travel away from the normal. Okay. So, we use this concept of total internal reflection in optical fibers. Over here, as you can see, this is cladding, this is coating, this is core. So, refractive index N1, this is refractive index N2. So, this is the normal drawn on this surface. So, light ray is coming on this interface at an angle that is greater than critical angle. This angle, let us say theta, is greater than critical angle. So, when this theta is greater than critical angle for this interface, what will happen? The light ray will undergo total internal reflection and it will travel along the core only. It will no light will go in the cladding. Okay. Similarly, this angle also is now greater than theta c. So, total internal reflection, and the light will travel along the core. If the angle of incidence is greater than critical angle for the interface, how much? It is about typically 82 degree. So, this has to be greater than 82 degree. The light is reflected back into the incident medium without loss by a process known as total internal reflection. So, it is very important to know about total internal reflection before studying fibers, because it is the main concept due to which the light travels through the fiber, through the core. Okay. Now, next, some different type of optical fibers are listed in this slide. We can divide them into various categories. One is according to the material that is used. So, either glass can be used or fiber can be used to construct optical fibers. Another category is single mode and multi-mode optical fibers. We shall discuss in our next lecture what are single mode optical fibers, what are multi-mode optical fibers, which one is beneficial, what is the constructional difference between single mode and multi-mode optical fibers. And third is step index and graded index. Step indexed and graded index optical fiber. I told you that the refractive index of core is more than the refractive index of cladding. So, this change in refractive index from core to cladding, either it is gradual or abrupt. If it is abrupt, then it is called step indexed fiber, and if this change is gradual, then it is called graded index optical fiber. This also we shall discuss in next lecture about different kind of fibers. Okay. So, these are the references that we can see. This was all about the basics of optical fibers. In next lecture we shall discuss about different type of optical fibers and few important parameters about optical fibers. Thank you.